In today's video, we'll be addressing a query that came through in the comments section. If you have any questions of your own, feel free to post them below and we might feature them in an upcoming video. The ideal DC bus voltage for a three-phase VFD under idle, not running, condition should be approximately square root of 2 multiplied by the AC RMS voltage. Hence, for a 480 voltage, three-phase system, the expected idle DC bus voltage should be around 678 voltage. For a 415 voltage three-phase system, drive idle DC bus voltage should be around 586 voltage. The actual value of DC bus voltage is dependent on many parameters, some of which are AC input voltage, peak voltage, load on the drive, presence of AC line reactors, presence of DC choke, presence of isolation transformers. Due to these factors, DC bus voltage under normal condition could vary a lot. Typical reasons for having an overvoltage fault on VFD. 1. Regenerative feedback. If the drive is supplying current to a motor with a lot of inertia, then the motor could act as a generator, feeding voltage back to the drive during periods of deceleration. This is called regenerative feedback. This can also occur if the motor is a permanent magnet-type motor. Another possibility for regen is when the load is already running when the drive is trying to start it. Solution. 1. Increase deceleration time. 2. Program the drive to stop the motor. In this method, the drive would coast the motor to stop in a predetermined deceleration ramp fashion. 3. DC injection braking. For applications that require a fast stopping time, the drive can be programmed to inject DC voltage into the motor windings for predetermined time to brake the motor. Check with the drive manual if this option is available. 4. Dynamic braking. DB. If the drive has a dynamic braking option available, then an internal transistor will be switched on to dissipate the excess energy onto an externally mounted braking resistor. The dynamic braking circuit will monitor the DC bus voltage and would trigger the transistor to be tuned on in the event it senses a regenerative overvoltage condition. The value at which the DB transistor will be turned on is approximately 5% below the overvoltage fault threshold. For example, for a 460V drive, the DB resistor is switched on at around 760 VDC. 5. If braking resistor is already installed, the check for 1. Open resistor. 2. Defective braking transistor. 3. Undersized braking resistor. 2. Power factor capacitor switching. When an electric utility switches a power factor correction capacitor on their medium voltage lines, a transient voltage event is generated with a characteristic low-frequency oscillating waveform. DC bus inside VFD charges to the peak of the AC input voltage value. During capacitor switching event, the higher input peak voltage can temporarily boost the DC bus voltage and trip on overvoltage fault. Solution. This issue of drive overvoltage fault due to utility capacitor switching can be prevented by adding a line reactor or a DC choke to the drive. Note that this will only work to prevent overvoltage fault on drives that are in operation, running condition. When the drive is in an idle-on state, adding a line reactor or DC choke may not solve the problem with capacitor switching, and the drive could still fault on overvoltage. Thank you for watching, and don't forget to subscribe and like the video.